Hey, it's Mr. K. Let's talk about ionic bonding with Roman numerals and polyatomic ions. On your periodic table, you'll notice that some metals, particularly the metals in the center, have multiple charges. These are called transition metals. We represent these as copper 2 plus using a Roman numeral copper and then the Roman numeral 2. Copper 1 plus is simply copper 1. Secondly, these are polyatomic ions. Your periodic table includes a list or a table on the table of polyatomic ions, or at least the common ones. This is nitrate. This is NO3 negative. It looks like this, basically 1 nitrogen, 3 oxygens, and an overall charge of 1 negative. So the subscript 3 is telling you how many oxygens. The superscript negative is telling you the overall charge. So just like other ionic bonding, we will be balancing charges, and we will either identify the charges 2 or 1 by the Roman numeral, or we'll be given the charge on our common table of polyatomic ions. Let's look at some examples. Okay, copper 2 oxide. So copper 2 is telling me this is Cu2 plus, and we know oxygen is 2 negative. Note that that 2 refers to the charge of copper 2. To balance this out, we just need a single copper 2 plus to balance out my single oxygen 2 negative. However, for copper 1 oxide, where copper is plus 1 and oxygen is 2 negative, we need 2 coppers to balance out the 2 negative. So my compound formula represents that I have 2 coppers for every 1 oxygen. Now, where this can be troubling is that 1 positive refers to the plus 1. But if you look at the compound, it's exactly the opposite. The name is copper 1 oxide, but the formula is Cu2O. The name is copper 2 oxide, but the formula is Cu1O. What you have to recognize is that the charge allows you to figure out what the compound formula is going to be. It's not telling you the formula like the prefixes would in a covalent compound. So, Roman numeral, charge. You figure it out. Okay, last one here, just to see one of these polyatomic ions. So here's copper 2 plus. Here is NO3 negative. 2 plus, 1 negative. We need 2 negatives to balance out. Now, when we're writing that we have more than 1 NO3, we're going to use parentheses, and I'm going to say that I have 2 NO3s. And now that 2 is going to apply to everything in the bracket. So that means that I have 2 N's, and I have 2 O3s, meaning I have 2 times 3, which is a total of 6 oxygens. Okay. All right, I'd like to do one in reverse, just so we can talk about it. Let's do an example of MnO2. Okay, so Mn is manganese, and O2, well, just O for now, is oxygen. So this thing is going to be called manganese something oxide. If you look on the periodic table, manganese has a charge of 2 plus or 4 plus. We don't know which one to use. So what we can do is we can model it and we can figure it out. I have 1 manganese. I have 2 oxygens. Manganese has to have a charge so that it balances out the 2 negatives. This must be 4 positive. And then I write my Roman numeral to show that it is 4. Your Roman numerals, in case you do not know, are 1, 2, 3, V is 5, 1 less than V is 4, 1 more than V is 6. I'm going to finish this list up. And then I'm going to hope you have a lovely evening. 7, 8, 9, 10. Okay. Thanks a lot for tuning in.